Okay, so Audrey, you can't see this?
I
Let me
can
make
see it when it's small.
it small.
Mhm.
Okay, let me make it larger, because I have it very large. What about now?
Yeah, that's better. That's
That's
better.
better. Okay, that's on
Yeah, that's better. Yeah.
36. Okay, so what we will be doing today, we will be going over our homework, because I think you and Latoya had the same problems. Then we will look at variables and
Well,
expressions.
there's one that I didn't send. It's the x to the n power time x to the n, which is the product rule.
Oh, okay. Well, we'll go
Yeah, I
over.
had it, but I didn't forget to take this one too. But
Oh,
anyhow, you can
okay.
go through it.
All right. So we'll this is what we'll be doing. Well, we won't get through all of it because we're starting so late because of the problems. But anyway, we'll get through the homework and probably start on the variables and expressions. Okay. So let me do a new share and bring up the homework. Okay. We'll first do the practice one. Now, actually, can you see that, Audrey? Well, it's probably,
It's fine.
well,
You gotta make it a little bigger.
let's see. Okay, let me make it bigger. Okay.
Yeah, Miss Barbara, see, I send you my homework.
I
Yeah.
checked the homework and I sent back results.
Okay. Yeah, see it.
You see it, right?
Yeah.
Okay, and we'll go over it. Okay, let's see. Let me make this bigger.
Zoom, I had to keep going in and out of Zoom.
Yeah, I had a problem with Zoom. That's why I'm on late, because I kept it couldn't bring up my my dialogue, and finally I just I tried a different browser and it still didn't work. So what I did, I just shut down the computer and came back in. So then
Yeah,
it
I had
worked.
to do it 3
You did
times.
it, yeah. Okay, can you see this? Because Audrey said she had a problem seeing it. Can you see
Yeah,
this
I see
screen?
it now. It's a little bit better. It was bad the first time.
Okay,
Yeah, I can see it now.
Audrey, can you see it?
Only homework, practice, matching exercise. But all the
But
rest behind you can scarcely see it.
you can't see this. Okay,
Right. None of that I can't see it.
let's see. Let me make it bigger. Okay, see it now?
Yes, I can see that now.
The only thing that once I did that, it's gonna, well, let's see. Yeah, it changed it. But anyway, it changed the configuration of what I had. Let's see. Yeah, because I had, okay, well, we'll do our best. All right. Now with the matching. Okay.
That one that I did with Barbara was cool. I think I put the right answer. Did I put the wrong answer? I was like,
This product
oh.
rule is really coming out. Let's see, on the matching. Let's see. You had the quotient rule, power of a product rule. And this really is supposed to be X over Y. Let's see.
You could press undo.
Put that. Okay. The thing is, I can't make the big parentheses. I had it as a sort of like a brace, but when I went to the large print, you don't see it. But let me just see if I can. Let's see if I can take.
Hi, Ms. Barbara. Hi, everybody. I'm sorry, this is Chastity.
Oh, hello,
Yes,
Chastity.
Chastity.
I'm driving home.
Okay, so let me just put Y and raise that to the M power. Okay. Well, it's not Y, it's the it's not an M. It's the M is on the outside. Just see, I'm trying to figure out how best to do this. Since I can't really, I don't have the the symbol for the large parentheses. But okay. Here's what I'll do. Let me make this X slash Y. And let's see, left paren. And raise this to the okay, that's X over Y to the M. Okay. And take out the underline. Okay. Oh, thank you. Okay, so I'm going to take that underline out. Bring that over. So instead of X over Y, I'm making an X slash, you follow? And I'll put this X over M and underline over here on the right. And put my Y to the M here. So this will be Y to the M. And I'll take this out. Because what I had before was really from something I copied. And so I'm changing, I changed it to a Word file. Okay, now that's the quotient rule, power of a product. And number 3, negative exponent rule. X to the M. I'm sorry.
X to the negative M.
X, no. See, this is C, it's on the right, but see, when I went to the big print, it looks like this is 3, and then this C is supposed to be over here. And then the power of a, okay.
Okay, I can't see that. Really fine now. I'm not fine again.
I know, that's when when I make it bigger, then I have to tell you the letters underneath the numbers. Okay, so let me make that big. Now you can see it, right? But that power, that D is X to the M. Let me take this out. See what is happening when I go to the big print. Then this is, just bring that over. D, okay, X to the M minus N. And this is underneath that X to the M over X to the N. That's the D. Okay. X, and then put my power in. Can you see that, Audrey? See, I made it bigger. Do the next one, X, and take that out. And then these others I've got to make bigger. Okay. Make these all bigger. 36. Okay. So E is X to the minus M is, that would be X to the 1 over X to the plus M. So that's X. And let me put my exponent. Take this out, we're almost done. And then the power of a quotient. Okay, that's 6, and then 7. Okay, so now I have them all set up. I have, but they were like below each other, whereas on the other paper they're at the side. So let's go back to the top. Quotient rule, A is X to the 0 equal 1. 2 is power of a product rule. And B is X over Y to the M. That's X to the M over Y to the M. And then 3 is negative exponent rule, and then C is this. Okay, so we're trying to match them. Now, let me just say this here. A quotient rule is a division, right?
Yes.
A quotient rule is a division,
Mm-hmm.
and a product rule is a multiplication.
Multiplication.
In multiplication, you add the exponents. So, but when you say power of a power rule, that means you've got a power in parentheses and then a power
Parentheses.
outside of the parentheses. Okay,
Mm-hmm.
the power of a product rule. That means a product is a multiplication.
That is the one with the parentheses.
Yeah, well, a product is a multiplication. That means you have a multiplication and you have a power outside of it. All right, power of a product rule. That means a multiplication in the parentheses and then a power outside. Okay, so it would be something like if I gave it some numbers. Let's see. Okay, so if you had okay, a product is a multiplication. So if I had, say, like 2 times 3, that's a multiplication. I'll make it bigger. And then I put a power outside of it, and I said to the second power. Okay. Make that bigger and bold. Okay, so the product is the 2 times the 3. It's a multiplication, right?
Mm-hmm.
And then the power is applied to the product. And that would be an example. It's given like, which is the one, x, y to the m. In other words, 2 times 3 to the second.
Right.
That would be equal to 2 to the second times 3 to the second. Okay, so let me just write what I'm saying. Okay. So to follow those rules, that would be 2 to the second power. Let me put the second. 2 to the second times 3 to the second. So let me put 3 and then put the power. See, the power, so the difference now in the power of a product rule is that within the parentheses, you have 2 either numbers or you could have variables. And the multiplication makes it a product, and then you raise that to a power, which makes it different now from just the power rule. The power rule is just the multiplication. All right. The power rule is when you multiplying, well, it's you multiplying 2 and then you're adding. That's the okay. That's the rule for multiplication. When you multiply an exponents, you add the powers. Okay. But when you have a product within a parenthesis, then you raise each one of those items in the product to a power. Okay, which makes it different from if you had 2 to the second times 2 to the second, both having powers. Let me just do this with numbers. If you had 2, and that would be to the second power. I'll make it bigger after I put the powers on it. Okay, 2 to the second times 2 to the second. Remember, it has to have the same base. 2, and I'll say to the third. 2 to the third. All right. This multiplication having the same base. All right. So I'll make that bigger so you can see it. 36, bold. Now, when you multiplying, what do? You add the powers. So this would be equal to
2 to the 6.
3 plus
2 to the 4.
That 2 to the 5th. That's right.
Yeah.
The 2 to the, and I'll just put 2 plus 3. You add the powers. Okay. You see the difference? Same, the product rule, same base, you add the powers.
Mhm.
The power of a product rule, you have a product
Where is the
within the
product? Where is
parentheses.
the,
There's a product, 2 and
Mhm.
3, 2 times 3. So you have a multiplication within the parentheses raised to a power. So I just want you to see the difference between the power of a product rule and a power and a product rule. This is just the product rule here versus power of a product. Product rule is just the rule for multiplication of exponents with the same base, the base being 2. Okay, so that's the difference. So when you were matching, I don't think I made it clear before that when you have a power of a product, you're raising a product to a power. This is a product, a multiplication raised to a power. Whereas a product rule is you multiplying 2 entities with the same base and you add the powers. Is that clear?
Mhm.
Okay, now, okay, so
That's number 7, Miss Barbara.
no, that's not number 7. I'm just trying to show you the difference between what we call the power of a product rule. That's what
And the
this
product
is,
rule.
and a product
Oh.
rule. And you can do the same with a quotient, which is division, right? This is power of a product rule. And a product is a multiplication, where this is just what? A product rule. This is a product rule. Okay, and that means you multiplying with the same base, you can add the powers. You see the difference, Latoya?
Mhm.
Now you can apply that to your division, and you had a quotient rule and you
Yeah,
had
I
a
know
power
this.
of a quotient. You know the difference now because you can
Yeah, I
use.
know this one.
Okay,
I know when you multiply, you add the thing, and
that's right.
divide, you
That's right.
subtract. I
Okay.
know that part.
Okay, so let's go up and match these.
My matching was crazy.
Okay, the quotient rule is which number? The quotient rule is just going to be a division. So I think you had that one right? You had D?
Yeah.
Okay, so that was D. Right? Quotient rule was D. Now, the power of a product rule. That means you've got a multiplication within the parentheses, all raised to a power. So which one would that be? A, B, C, D, or G? A, B, C, D, E, F, or G?
G.
That's right. It will be G.
I was shocked I put F.
I was too. Audrey, you see that? Why that's G?
Mhm.
G
I don't know.
says,
I think I number my type of alphabet on mine. I don't know why I think I type of alphabet on alphabet letters on mine.
you put it on there. Because you and Latoya missed the. I think y'all missed the same ones, almost the same. So 2 would be G, because when you look at G, it's X times Y all raised to the M. The product being X, Y, and the power being M. So it's a power of a multiplication. Got it?
Mhm.
So that's number 2. Okay, let's look at number 3. Now you had that one right, negative exponent rule. Which one was that, Audrey? What was the letter on that one?
0
Negative.
exponent rule.
That what's for 3? What letter goes in the blank? Which one shows a negative exponent rule? In other words, the,
X negative M. Next to the X to the negative M.
that's right. That was E. Yes. I think you all had that one right. It was, I think it was the power ones that you didn't get right. Now the power of a power rule. Power of a power rule. In other words, a power in parentheses raised to a power. Which one is that? Which one is that, Latoya? A power in parentheses and then outside the parentheses another power. Which one is that? That's C.
See?
Yeah, this one is C. Because C says what? C says, oh, C is X to the M all raised to the N. I think originally I had a power rule, but to make it more descriptive, it should be power of a power. So you have a power in parentheses and a power outside of parentheses. So 4 should have been C. And you all had this one right. 5 was what? Any number to the 0 power is 1. So that was what? A? Yeah, that was A. And what is 6, Audrey? Power of a quotient. A division raised to a power. Where you subtract the exponents. Yeah, which one is number 6? What alphabet?
Number 6. Okay, read that again.
Power of a quotient rule. Now this one is a division. Say
Power of a quotient rule.
Yeah, a division, you subtract the exponent, right?
Exponent, yeah.
So which one is a division?
Exponents. I don't know, they got me mixed up.
The power of a quotient rule.
Yeah, power of quotient
Well,
rule.
this is the power of a quotient rule. That means you have a division to give you a quotient and it raised to a power.
X over X to the M over Y to the M.
X over Y to the M. Yeah, which is X to the M over Y to the M. And that would be what? B.
The power of quotient.
The power of a quotient rule. In other words,
number 6, that's number what?
Number 6 would be B.
That's number 6?
Yes, because B is a division. You get a quotient when you do a division. So your division raised to a power, that would be X over Y to the M.
Okay. And the one in the parentheses is what number is that? You say I have them right, but he didn't have the number right next to it. That's what happened.
I'm sorry.
Okay.
And what is 7?
6 is B.
The product rule.
6 is B. The product
That's
rule
the multiplication
is
where
X
you
times the X to the N times X to the N.
And you get X
equals
to the M plus N, right? That would be the F. Yeah.
Okay, so the
Product rule is a multiplication. In multiplication, you add the exponent. So that would be F. X to the M times X to the N is X to the M plus N.
Right. That's the product rule.
That's the product rule. Product rule is multiplication. Quotient rule is division.
Number 7. This is number 7. I got it. Wait, no, but I got it numbered off.
So that would be the matching. Okay. These are the letters you had. Now some of them you had right.
Number 5 was 0.
Okay. Here we go.
Number 5 was 0, right?
1 is D, quotient rule. 2 is G.
Wait a minute. Yeah, quotient rule.
Okay. 3 is negative exponent rule, because E says what? X to the minus N is 1 over X to the N.
Number 3.
Yeah, that's where a negative exponent is equal to a 1 over the positive exponent, right? Okay. And then the power of a product rule, that's the one where you have a power in the parentheses raised to a power outside. So that's C.
Mhm.
And then, of course, any number raised to the 0 power is 1. So that's what A says, x to the 0 equal 1. And then B, power of a quotient, that's a division raised to a power. That's B. And of course, the product rule is F, it's multiplication, add the exponents. That's it. Any questions? Audrey, you have questions on it?
It's the product.
So those should have been your answers.
Number 7.
The thing is, once you got one of them wrong, you're gonna have
Okay,
another
I
one
have
wrong,
it.
right? Because whatever you use should have been someplace else. Okay.
I had to rewrite it. Because I wrote it down, but I didn't put the numbers next to it. So now I don't know which one is which.
No, you trying to match. See, over on the right side, you
Yeah,
had,
I was
you
trying
had
to
the-
match.
you had
I
the
matched it, but then I
letters.
didn't put numbers. I didn't put the letter that it represents.
Yeah,
I just
well,
put
in
down
order
the
to
word.
match them, you have to put the letter on the right that matches.
Right, that's
the
what I didn't
rule.
do. See, so that's what got me a little confused here.
No, you
By
have
looking
them.
at it, I know I can see it, right? By looking at the
Yeah.
X times the XN, and I can see that that's a product rule, you know, but I didn't put down the letter, the
No,
number.
you didn't have to put the number. You put the wait, Audrey, you did. You put the letter on the number. Yeah, because you sent it to me and you did it because okay, yeah, because you put 1B, you put 2F, 3E. So you did it right. You put the number and the letter, and then you said 4C, 5A, 6G, 7A. And Latoya did the same. She put 1D, 2F, 3E. No, you did it right, except when you put in the letters, some of them were incorrect for what it applied to. Okay. But now I'm putting your correct answers there. Now, there's something I didn't explain to you so well, and I think it's why you missed some of the ones on the next. The simplify. Now, you got this one right. Latoya, and you had that one right. What did you get? That's a multiplication. You add the exponent, so you got 7 to what power?
22.
1 is 2. That's right. 13 plus 9. Okay. Now, the next one, you and Latoya missed. And I think it's because I didn't make clear to you something. Now, 6x to the 4th to the 3rd power. That means you got to raise this 6 to the 3rd power and multiply the 3 by the 4. And I think you didn't do that. I think you only looked at the exponent.
Yeah, I look at the 6x and I put 6x to the 12. That's what I put.
Yes, I know that. And I think Latoya did the same. You have to see, this is really 6. This is 6 to the 3rd. Let me just write it out.
6.
This is 6 raised to the 3rd power. Let me put the 3rd
third
power. Okay. And this is times, let me just put it here. This is x, and I'll put the 4th here to the 4th power.
Times x
and
to the 4th power.
A close paren, and then to the 3rd power. So you have to raise both that 6 and the x to the 4 to the 3rd power. You got it?
Okay.
So that's the one you missed, and I don't think I made it clear to you, but everything within the parentheses, the power applies to. So you have to raise the 6 to the 3rd power and the x to the 4 to the 3rd power. So what is 6 to the 3rd power, Audrey?
6 to the 3rd power is 18.
6 times 6 times 6.
No, oh my goodness. 18.
6 to the 3rd means 6 times 6 times 6. 36 times 6 is what?
196.
36 times 6.
196, isn't that right?
6 times 6 is 36. And then 36 times 6 is 216, isn't it? Put over here.
36 times 6 is 196.
6 times 36 equal, and you said what?
196.
What's 6 times 6 is 36 and 3 to carry, and 6 times 3 is 18. And what's 18 and 3? 21, isn't it?
6 times 6 times 6.
Yes. It's 6 times 6 is 36 times 6. Isn't that 216? You getting 196.
This is 36, 16, 18. Oh, yes, 216.
216. So you're gonna
Yeah.
have 216 for 6 raised to the third power, and then x to the 4 times x to the third would be x to the 12th. So this would be a 12.
So she says 216 to the what?
216 x to the 12. No,
Oh,
because
x to
you
the
have to
12.
multiply. Remember, outside the parentheses, you have x1, and inside, so it'll be 3 times 4, and that would be a 12.
Mm-hmm.
Got it?
Mm-hmm.
So that would be the answer. 216 x to the 12.
We was way out.
Yeah, you and Latoya made the same error. You didn't raise your 6 to the third, but remember everything within, you apply this
parentheses.
third power to everything that within the parentheses. Both this constant 6, a coefficient, and the x to the 4th. So your answer would be 6 times 6 times 6, which is 216, and then x to the 4th raised to the third power is 3 times 4, or 12. So your answer would be 216 x to the 12th. Got it?
Mm-hmm.
Now, you and Latoya both had this one right. This is what? Division. So you subtract the exponent, 9 minus 4. So this will be 2 to the, and let me just make that 9 minus 4, because you subtract the exponent, right? So that would be equal to, what would that be, Audrey? 2 to the what?
2 to the 5th.
2 to the 5th. Very good. Because that would be 4 from 9 gives 5. And you had that one, you and Latoya had that one correct. Okay, let's look at the next one. 2 to the 6. Now this one, it said simplify, and you and Latoya both just gave me 2 to the third. Let's see this one. You gave me 2, and I'll make that bigger. Okay, to the third. This is what you gave me.
That should be 1 to the third.
No, you gave me 2 to the third over 6 to the third,
Yes.
right?
Mm-hmm.
And I gave you credit for it, but it really, you have to
Simplify it. Break it down.
simplify it. That's right.
Right. Yeah. Break it
2
down, so it'd be 1/3.
to the, I
Right?
mean 6. This is 6. Yeah. So that would be 6. And let's put third. 2 to the 2 over 6 to the third is 2 to the third over 6 to the third. So let's make this bigger. This is, okay, that's 16. Okay, so that's 2 to the third. But now to simplify this, you would have to do what?
Cancel.
No, not cancel.
Divide it.
What does 2 to the third mean? 2 times 2 times 2 times 2,
times 2. Mhm.
right? So
Uh-huh.
you would have to, okay, that's equal.
8. 2, 2, 4, 4,
What's
2,
2
8 to the third.
What's
That'll be
2
8.
times? Okay, that's right. That would be 8. 2 times 2 times 2 is 4 times 2, which is 8. That's right. And what is 6 times 6 times 6 times 6? 6 times 6 times 6 is what? Audrey, what's 6 times?
196, right? 6 times 6 times 6 is the same 216.
Yeah, 216. Okay,
216.
so let's underline and put 216. Okay. And is that simplified?
Mm-hmm.
Can you what we call reduce it, or
Yeah.
it's simplified?
Mm-hmm. We gotta do it now.
No, it's not simplified.
I said we have to do it now.
Yeah, so what would it be? What
To
would, let's see.
56.
Actually, you can divide by 8.
8, right?
So 8 divided by 8 is 1. And 216 divided by 8 is 27.
You know, Miss Barbara did it on the calculator, the 6x 2, and I get 216, and I thought it was wrong.
How can you think it's wrong? Toya?
I said the calculator is telling me wrong things. So I put
No, it's 216. So your answer simplified will be 1 over 27. Got it?
Oh
Yeah.
boy.
Now, I gave you the credit for this one because, well, you looked at the formulas that was in the first part, and 2 over 6 to the third is 2 to the third over 6 to the third, which is fine. But when you simplify, you really want to do what? You want to get it to its lowest term. Okay.
Oh.
So your answer, your final answer, like if you were given something like this in multiple choice, 1 over 27 would be one of your answers. Okay.
And the even them would have put it 8 over 216, and you leave it as that.
Now that would not be your choice because
That's what I'm
very
saying.
seldom the answers are not simplified at the lowest terms. In other words, the fractions at the lowest term. Okay, so that was D. Now E, you got that one.
Yeah.
What is that one, Latoya? I think you and
1 and 193. 1 divided by 9/3.
1 divided
1
by what?
No, 1 over 9 and the 3 at the side. The exponent is 3.
Okay,
1/9 and the
1,
exponent is 3.
and I'll do it as a slash 9, and then that 9 is raised to the third power.
The rest to the third power.
Yeah, it's the reciprocal of the, it's the reciprocal of the 9, which is 1 over 9, and then the exponent is then plus instead of minus. Okay.
This one I couldn't get. I didn't know the other one.
Well, this one was similar to one we had before because you have what? 5 to the 4th power is what? 5 times 5 times 5 times 5. What is 5 to the 4th power?
125.
120. 5 to the 4th? No. It's 5 times 5 is 25. 5 times 25 is
100.
125. And then 5, what's 5 times 125?
575.
Latoya. Latoya.
125 times 5, 5, 5 is 25, 5 to 10.
Latoya, let me ask you, what's 5 times 100?
500.
What's 5 times 25?
50.
Latoya. Latoya, are you okay? What's 5 times 25?
5, 5 to 10. 105. No.
Audrey, what's 5 times 25?
5 times 25. 125.
It's what? Say it again.
125.
125. And what's 500 plus 125?
525.
625.
625.
625.
625. So that's going to be 625 for that 5 to the 4th, right? 6, 2, 5. So now you got 625 x to the 13th power.
Right, yes, sir.
Okay. And I'll put asterisk here for times, and that's times 5x to the 3rd. Now you do what? You'd have to multiply 625 times 5. And what do you do with the exponent, same base? You add the exponents. So what would be the answer, Latoya? Tell me the answer. Give you a chance to figure it out. What would be the answer? Five times 625, same base x, add the exponent. So what would be the answer?
Same base as the exponents. Okay, so that would be.
You got it, Audrey? Latoya,
Yes,
you got it?
3,125 to the 20th power.
3,125 times x. And what's the power?
20, yeah, 20
What's 13 plus 3?
is 16. I wrote the 4.
16. That's why you didn't answer me, Miss Barbara, because I have you on mute. And I'm here talking to myself.
Yeah.
And what happened to the 4, Miss Barbara?
What, Audrey, you said what was the power on the x?
16.
16. Audrey said something very different. Audrey,
Yeah,
where
it's a
did
20.
where did you get
I added 5
20?
to the 4. I got that 5 to the 4, whatever that is there. Unless I write something different. It wasn't 5.
Audrey,
Huh?
wait a minute. You took 4 and 13 and 3 and you got 20, right? But you can't do that. 5 has a different base. You can only add exponents when the base
you're
are the
right.
same,
You're
right?
That's right. You're right.
So the
You're right.
x and the x are the same
X and
base,
the
but
X,
not
that's
a
right.
5. So
Right, that's
we
right.
raised the 5 to the 4th power and we got the
Right.
625.
Right.
Okay. Then you add the 13 and the 3, same base
Okay, we get
x,
16.
add the powers. So that would be 3,125 x to the
X
16.
to the 16th power.
That's
Oh.
right. Got it?
Oh gosh.
Be careful when you
messed up.
have these coefficients in front of these other exponents with variables, because you've got to do the coefficients first.
You
gotta
know what? I
apply-
didn't really recognize it that way. I didn't
Huh?
recognize it like that. I said I didn't
You-
recognize that, you know.
You didn't recognize, but see, remember I said the rule for the multiplication, the bases have to be
Yes,
the
but when I was
same.
doing it, I just said, okay, 5x plus this, that, and going on, you know.
Yeah, but you have to be really careful.
Yeah, I gotta be careful.
Because, right,
with that one.
because that base is 5, that base is x, that base is x, right? So you can't do that because the bases are different. This is a 5, that's an x. So you can't add those 4 and 3 exponents. Only when the bases are identical. Got it?
Mm. Yes.
Okay, so let's go to G. Now you could probably do G now, right? Or did you do G? Latoya, did you do G? I think somebody had that one right.
I have
Well, no, I don't think you did. You didn't,
2
because
to
this
the
is
5th.
2 to the 5th is what? What's 2 to the 5th? Because we've got to take 2 to the 5th power.
64 to something.
2 to the 5th.
Mm-hmm. It's 64 to the 5th. It's 64.
What's 2 times itself 5 times?
64. You right?
Is it 64? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. It's 32. right,
2 to the
Audrey?
5th is 32. 2 to the 5th is 32.
Multiply it out.
Okay, 2 2 is 4.
Multiply
4
2
2
by
is
itself
8,
5
8 is
times. What do you get?
1, 2, 3, 4, 5, yes. 32. 2 to the 4, 4 to the 8, 8 to the 16, 16
I
to the
get that
32.
one
Yes.
wrong.
You got
32, yeah.
32. So that
Yeah.
would be 32 x to the 8. So let's put the 8 on there. Okay. And now we've got 2 to the 4th.
Oh, you know what? I put it out as a multiplication, you know. I put it 2, I put 2 to the 5th times 8. That's what I do. That's how I make my mistake.
Yeah, that's again, your bases are different.
Yeah.
Can't do that. Different bases. Okay. Now, what's 2 to the 4th? 2 times,
16.
that's right, 16. Okay. Get rid of this on the line. Okay. And that would be x to the 10. Let's put our 10 there. Now, what's 32 divided by 16?
2.
2, that's right. Okay. So let's just, so that's equal to, and 32 divided by 16 is 2. And what do we do when we dividing exponents? What do we do with the exponents?
We subtract them.
That's right. Very good. So that would be 2 to the 8 minus 10. What is that equal to, Latoya?
A minus 2.
That's right. So that would be, let's put an X. We've thrown away our X here.
I know, yeah, that half.
Should be X.
Oh, man.
X. Okay. So this would be equal to,
Mhm.
Latoya said 2
Okay, how
to
do
the
it?
X,
32.
2
Okay, so
to
that's
the
2 to the 5th.
X, and minus 2.
X
So
to the
let's put
8.
our minus 2 here.
2 to the 4th.
Now, what is that equal
to the
to?
10. This is 10, this is 32. X to the 8th.
What is that equal to, Audrey?
Huh?
2 to the X minus 2. What would that be equal to?
X to the
What do we do with
2
the negative exponents? 1 over the reciprocal, right? So that would
Yeah.
be 2.
2 and a half. 2
Uh-huh.
over 1.
No, it would be
No,
2
no, it is
over
2
X to the
2 over
second.
X to the
Oh.
second, yes.
Okay. So
Okay.
that would be 2 over X to the second. So we put in the denominator here, X to the second. So it's reciprocal of the positive. So X and then to the second.
2X.
That's your answer. 2 over X to the second power.
equals to
Got it?
2X.
There again, now you've got to, you can't say 5 and 8 are 13 because those bases are different. Here's a 2 and here's a X. Like here's a 2 and here's a X. So you can only apply the adding of the exponents for multiplication when the bases are the same. Just like the one we did with the 5. Okay. Questions on G? And you both had this one, right? 17 to the 0 power. Anything to the 0 power is what?
1.
1. So the answer is 1. Okay. And the last one.
8 to the
Multiplication.
minus 4.
That's right. Very good. I think, or did you have that one right? I think you had that one right.
8 negative 4?
Yep, that's right. Because you add the exponents. Minus
Yeah.
6 and a plus 2 gives
Plus
you
2,
minus
yes.
4.
Yes, I get that
Okay.
one.
Okay.
I
So
didn't do too
now,
bad though.
yeah, no, you didn't do
Yeah,
bad.
right?
You didn't do bad. The only place where you and Latoya both went wrong was,
parentheses one. That,
yeah, but where you and
the power.
where you both went wrong is like when you had like this kind of example.
The parentheses and the other one.
Yeah, no, I mean when you had different bases and you tried to apply your rules and the bases are different. like that one.
So when you see it
and the
like
one
that, you
here.
gotta multiply it out, right?
That's it. Absolutely, Latoya. When you see the bases are different, like here you have a number and you have a variable, you've got to simplify that 2 to the 5th. 2 times itself 5 times, 2 times itself 4 times. Okay.
Yeah.
All right. You'll see some more of those to practice. Okay.
Yeah, it
Now,
has helped me a lot.
what the practicing?
Yeah, because my algebra is crappy.
Yeah, well, the more you practice, the better you become. I mean, it just that's the way it works. Well, we'll start on our new topic. Let's see. We want to do a new share. And we're going to, okay. Variables and expressions. What's a variable, Latoya?
A variable
Yes.
is a letter of the alphabet.
Yes, it's a letter of the alphabet.
And it is used in algebra.
Definitely used in algebra. Yeah, and we see X and Y
and it's
used a lot.
considered as 1 in some cases.
What's considered as 1?
The X. The numeral sometimes it's considered as 1.
When do you use a variable as 1?
I don't remember. I know you use it for something as 1 though.
Latoya, I have no idea.
Maybe I'm mixing it up.
I think you are. I think you are. Okay, so a variable, like you said, is any of the alphabet A to Z, but a few variables when we representing numbers, we kind of stay away from. One of them is E, and because E is a constant for Euler constant, and we generally try to stay away from that one. And also we use X. There's another variable we generally don't use. What is it? Can't think of the name. Which one?
They hardly use B.
Why?
They always use X for a lot of stuff.
Well, they use X and Y a lot, but you don't have to. You could use Z, Q, whatever, okay? But anyway, it's from A to Z. Now I have a diagram here so you see what a variable, when you have an expression. Now, what's an expression, Audrey, when you say expression? We're talking algebraic expressions. What would you say an expression is?
I'm not sure.
Well, just give me an example of an expression.
Like people say first expression counts.
Oh, I love that, Latoya, but it really is not math you're talking about here.
It's the same thing. It's like you gotta be given
Well,
an expression about something, you gotta express yourself like how you ask us to express the math. Like
yeah,
what
but
is the quotient?
math expressions, well, this is one right here, 5x minus 3. Now, math expressions don't have to, they're not equations. See, equations would have an equal sign, right? But an expression just is made up of terms. And they usually separated by a sign, a mathematical sign, it's plus, minus, multiplication, division. Now, this 5x minus 3 is an expression. And it's made up of, well, this one, of course, is made up our coefficient, the number in front of the variable, and the constant, which is a 3. And notice it has a minus. So expressions have, well, to determine what makes a term is what's next to the sign, to the symbol for either adding, subtracting, multiplication, and division. And this is a term. 5x is a term, 3 is a term. And when we get into polynomials, you'll see they all have more than one term. All right. So know what a term is, know what a coefficient is, know what a variable A to Z, and then algebra, like Latoya says, is used in algebra, and it represents the numbers. And then the constants are the numbers. All right.
Oh, I didn't know this part.
What? I'm sorry.
That the 3 was a constant. Wow.
Yeah, the 3 is a constant. The
That's the
numbers
first
are
time I'm
constant.
knowing that.
Yes. Well, when you have an equation, you can have variables with coefficients. You can have variables without coefficients, and you can have numbers. Okay. Now, variables, before you really can get into solving equations, you must understand variables, and you must know how to evaluate algebraic expressions. Now, we went through this, variables, what they stand for. Now, variables we use to change expressions into algebraic expressions. You've
Can
seen.
you make that a little brighter, Miss Barbara?
Oh yes, I'm sorry. I meant to do that at the beginning. Okay. Yeah, let's make this 36. 36 is a good one, you can see, right?
Yeah.
Okay. And this is what we went through. Okay, here's the ones they say to stay away from. The E, because that represents the Euler constant. And then I. What does I represent, Latoya?
Hmm?
What does I represent?
Hmm.
Do you know what that represents,
No.
Audrey? I.
No.
Imaginary numbers.
Oh.
Square root of negative numbers are imaginary. We use I to represent them, okay? And of course, we try to stay away from the letter O because it can be mistaken for 0.
Yeah.
All right.
I
Now,
see I said B and you have B in at the top. I guess B.
no,
One of the
E
things said B.
and I don't know about B. I mean, these are the ones I found that you want to stay away from. Okay, now I want you to be able to look at an expression. Okay, I want you to be able to look at an expression and translate it from the words to the math. And we gave you some common ways they represent, say, addition, subtraction, multiplication, division. Right? Addition, more than, greater than, increase. Sum, subtraction, minus, less than, smaller than, decrease. Let's look at multiplication and division. Okay, make that bigger. Multiplication. Remember, we just went through product with our rules for exponents, right? Product, multiplication, times, multiply by of. Of you see a lot. Where do you use of? You say 15% of
word
100.
problems.
Yes, that's right. 50, and with percentages, when you say 85% of something, you really saying multiply by the fraction
100?
0.85 or 85 over 100. Okay. And division, divided by, and a ratio. A ratio is a division. 1 over 2 is a fraction, but it's also a ratio. Now, let's look at how we can translate some algebraic expressions. Let's see. Let me bring this down. I want to go to the next page. Okay, now I have some I want you to do. These are some examples. I want you to give me an algebraic expression for these. And I don't want this to renumber. Let me undo this. Okay, the sum of a number and 5, Audrey, what would you say? What would be the algebraic expression for the sum of a number and 5?
Plus,
You have to give me the whole expression, which
uh,
means you're going to give me a variable. You're going to
addition,
give me an operator, whether it's plus, minus, multiplication, division. And then, of course, you have a constant here because you have a 5. So give me the whole expression that represents the sum of a number and 5. You're translating that to the math. So tell me what to write.
2 and 3.
No, that's not an expression. A number. What are you going to call that number? What variable letter are you going to call a number?
What?
A number. You're going to represent that with a variable. Tell me what variable you're going to use. Anything from A to Z.
Y,
Okay, so you say Y. And sum means what?
to add,
Add. So what's the symbol for adding?
a plus sign,
A plus. So Y
plus 5.
plus 5. That's it. That's the answer. The sum of a number and 5 is a variable. That's for the number. The plus for the sum, that means sum. And then 5 is what you're adding to that variable. You got it?
Mhm.
It could be Y plus 5, could be A plus 5, could be N plus 5. Well, you know the sum has to be a plus. This is a term. This is an expression. Y plus 5. Got it?
Mhm.
So I said, give the algebraic expression. That's the algebraic expression. Latoya, the number minus 4. Give me the algebraic expression.
X minus 4.
Very good. X, that's the number. Minus is for subtraction, and 4 is what you're subtracting from it.
This
Audrey?
all the algebra was so this easy.
Okay, Audrey, that's clear to you? Okay.
Huh?
You agree with Latoya?
What did she
X.
say?
X minus 4,
Yes.
the number minus 4.
The number- yeah.
You have a variable, you have the minus for the you have the subtraction sign for the minus, and then 4. Latoya, 6 times a number.
6x.
6x. Latoya, don't overdo the x. Give me another variable. 6x is right.
6b.
6b, okay.
Because they always use x. So
They
you
always
don't
use X. That's why I want you to get accustomed to use, because sometimes you want, when you given a word problem, you may not want to use X. You may want to use, like if you give people's names, you may want to use the first letter of their name to represent, say, like Albert had 6 oranges. John had 4 times the number of oranges that Al had, or whatever. You may want to use the a letter of the person's name. So 6 times a number, times mean multiplication, right? So
Yeah.
6, and remember, multiplication can be side by side, right? You can have 6b. You could have t times 6. That's 6 times a number, right? But most times when you have like 6 times a number, you do the side by side. But you could use the X or the asterisk or a dot, or you could even use parentheses, right? That would be
Mhm.
6 times a number. So if you were given a multiple choice, and you'd have, this could
The
be
guys say come and lobby.
T
The guys say come and lobby.
times 6. Okay.
Yeah,
Okay. All that
you
represents
gotta go
6.
now. Cause you have attitude. I'm not with the attitude.
Okay. Audrey, X divided by 7. What's the answer?
B over 7.
X divided by 7.
Oh.
What's the, notice I gave you a variable here. So what would that be as an algebraic expression?
Okay.
X
Two-
divided
two-
by 7.
2 over 7.
Where are you getting a 2 from? Where are you getting a 2 from, Audrey?
Okay. She sent me an X over 7.
I said X divided by 7. How would I write X divided by 7?
X over 7.
That's right, X over 7. And I'll just do the slash here, X over 7. You could put a dash, but I'm just doing the slash, X over 7. X divided by 7. The divisor is the 7. The dividend is the X. Or if you want to say in fractions, X is the numerator, 7 is the denominator. Okay, Latoya, are you there?
Yeah,
3 more than the product of 2 and X. More than means add, product means multiply. Tell me what to write.
there's gonna be 3 plus 2x.
3 plus 2x. Okay, 3 plus 2x. Or what? 2x
X plus 3.
plus 3, which is the same. That's from you commutative laws of math. That 3 plus 2x is the same as 2x plus 3. 2x is product of 2 and x, and 3 is plus 3 is more than. More than means add. Okay, Audrey, are you okay on that one?
Mm-hmm.
3 more than added, product of 2 and x, multiplication. All right. And you don't need to say 2 dot x. You could just put side by side. This is a case where it's actually clear to have it side by side. Now, Latoya, this one. 4 less than 10 times a number.
4 minus 10.
Audrey?
No, 4 divided by 10.
She said 4 less than what?
4 less than 10 times a number.
4.
Now, less than means subtracting.
Subtraction,
10
yes.
times mean multiplication.
Multiplication.
So what would that be, Audrey? What would that be as an algebraic expression?
Okay, that'd be 4 minus 10x. I'm not sure if we're doing it right.
Think about it. You're getting it reversed, because 4 less than means you will subtract the 4
4, yeah, from the 10,
So-
right?
from the 10.
Right. So that would be 10 minus 4x.
Well, no, 10 times a number would be what? How would you represent 10 times a number? You said 10x?
10 times 40. 10 times 4.
No, 10 times a number. How do you represent 10 times a number? You said it before. You said 10x.
Okay. 10x. 10 times the number.
Let's say 10n. We lose a different variable. 10 times a number, we say 10n. Now, how would you show the 4 less than that?
Minus 4.
That's it. Very good. Okay. Minus 4, because 4 less than means you subtracted 4. Now, this kind of expression is one of the few times where whatever comes first actually comes last in the expression, because 4 less than means
this
4
years
is
ago. I can write it.
subtracting from something. So 4 less than 10 times the number means you take 10 times the number and you take 4 from it. That makes 4 less than. Latoya, you got that? 4 less than 10 times the number. 10 times the number n minus 4. Questions? Okay. Now let's go to Latoya. You clear on that? She must be getting her cab. Okay. Now we're going to evaluate some expressions. Okay. Make that bigger.
I'm here talking to you, I'm on mute.
And I was asking you, did you understand this 4 less than 10 times a number?
Yeah.
You take 10 times a number, you subtract 4 from it. Because this
Yeah,
is the
I'm
one
talking
that,
to you, I don't realize I'm on mute. Lord Jesus.
okay, let's
Lord,
look
I'm
at
there.
evaluating some expressions. Okay. And it's better, I mean, I gave you some words, but it's better just to do them examples. Now, evaluating something means you've got some expressions and you've given some values of the variables and you're making substitutions. Okay, that's all that is. So you've got the expressions, and before we didn't know what those variables values was, but for evaluating, you're given the value of the variables that you want to apply. Okay, let's just, okay, x plus 2y. If x is 2 and y is 5, that means wherever you have an x, you want to put a 2, and where you have a y, you want to put a 5. So, Audrey, what would x plus 2y be equal to?
$12.
Okay, so you said x is 2, right? So we
Right.
put a 2 plus, this is 2
that'd
times
be
y, which is 5.
10xy. That'd be 10xy.
2, no, I think you were right, times 5, no, you're right, equals 2 plus 10, which is 12, which is what you had, and that's correct. And I'm just writing it out so you see how we got it, 12. So where you had an x, you substituted a 2. This is substitution of the variable. Where you have a y, you put a 5, and 2 plus 2 times 5 is 10, and the answer is 12. Latoya, number 2, what's the answer?
5.
Oh, this is number 2. Let's see.
Yeah.
Get rid of that. A plus BC minus 3.
4.
A is
4
4.
plus 5.
Okay, let me put, you tell me what to write.
B is 5.
Okay, A is 4, so you put 4
Plus
plus, and what's BC?
5.
Okay, so I'm gonna put that 5. What? What's C?
C is 6.
So that's 5 times 6, right?
Mhm.
Because it's BC, that's a multiplication. So it'd be 5 times
Yeah.
6, and then you have what? Minus 3.
-3, yeah.
Okay, so that's equal to what?
6 times 5 is 30.
Okay,
30 plus 4
that's
is 34.
30
-3,
and minus
Minus
3.
3.
And what is
31.
that equal to?
31. Minus
Okay.
31.
No, not minus.
31.
Yeah, 34 minus 3 would be equal to 31. That's it. Substitution of the variable. That's what you
That
call,
part is not bad.
yeah, we call that evaluating our expressions. All right. Now we've got another one here. That's number, okay. Audrey, do number 3. Okay, let me undo this. I want you to do number 3 and tell me your answer. Give you a couple of minutes. Latoya, you got time to work on it?
Yeah.
I know you getting your ride or whatever, but do you have time to do that one?
Yeah.
Now that's m to the second power. Let me just move this over a bit. Okay. And m to the second power plus 4 times n plus 1. M is 3 and n is 2.
It's gonna be 9
So I want,
plus
let's
4,
see.
To the second, right?
13.
Yep.
M is what? M is 2?
M
Wait a
is
minute.
3.
Yeah.
M is 3. Okay, right. Okay, M is 3.
And
Latoya,
she
what
said,
do you get? What do you get, Latoya?
I get
What's your
18.
answer?
I get 18.
18.
You get 18?
No, it's 9 plus
N is
Lat-
2, right?
13, 16.
4.
16,
Latoya,
Miss Barbara.
okay.
Yeah,
you got
3 square is 9.
Right?
And 9 plus 4 is 13.
4 times
Plus
2.
2, 15.
4 times 2.
Oh,
What is it?
sorry.
8
4 times
plus
2 is
9 is,
sorry.
what did you say,
17
Audrey?
plus 1, 18.
It says 18.
We
That's
said
right.
18.
I'm sorry, you're right. 18.
We've been saying 18, and you say no.
I know. My error. That's my error. No, you're right. Answer is 18.
We get a score, Miss Barbara. Extra points.
You're right. You get extra points for being so fast. Okay. So the answer is 18. So let me don't do this renumbering. And okay.
Excuse me, Barbara.
Yes.
So I'm going to come out of the system because I'm going to leave, but I'm going to leave you as the host.
Oh, okay.
Okay.
All right.
All right.
So answer is 18. I think we have one more to do. Okay, we got one. We have some more to do, but I just want you to do this one. B plus C over 7 plus C over A. A is 2, B is 3, C is 4. Can you see that one? Let's see if I can make it bigger.
Yeah.
That was one I copied.
B is 3.
Okay.
3 plus 4.
Okay. So do that one. B plus C. A is 2, B is 3, C is 4.
4 is 24. Three, wait a minute, B is 3,
4.
B is 3, so that is 3.
Any answers?
C to the 4th. No, wait a minute.
A
The bottom
is,
part is A or what? What's
that's a
C
A.
over
Yeah,
S?
C over A. That's a A right
Oh.
there. Okay,
Okay.
that's a A. A is 2, B is 3, C is 4. Any answers?
It's B is 3 plus 4 over 7.
And 7 over 7 is what?
Cancel out.
4. Oh, you got it wrong then. 6B is C.
7
C
over
is
7. That's nothing.
4.
No, 7 over 7 is 1, Latoya.
3, 4, 7. I get that one right.
Isn't 7 any number of itself? A variable of itself is 1.
I got messed up. 3 and 4 is 7 over 7 plus
Plus
4 over 2.
4 over 2.
That is
4 over 2 is what?
2.
So what's the answer?
2. 2 plus 1, 3.
2.
That's it, 3. Very good. Answer 3. Is that what you got, Audrey?
No, I didn't finish it.
What happened?
messed up.
Latoya, say what you did.
B is
What happened? What
B
I did
is
is I
3.
missed right before already C's and I taking a note that it is 4 to the power. That's what made me messed up.
What
I
did you
should've
do,
written it out.
Audrey?
No, I missed and right. When you call out the letter to me, I just write it over the number of the letter, so that's why I get messed up.
You didn't have the B plus C, 3 plus 4?
3 plus 4. Yes, I had it like that. I had it on the other way around. Or 7.
What's the other way around?
I had it. I put the 4 up across the C, like if I making a to the power thing, to the power. When you call it,
Oh, okay.
over the C, right? I
All
messed up.
right, no powers now. This is
Over
straight
7.
addition.
3 over
Straight
7.
addition. 3 plus 4 is 7. 7
Plus
over
C over
7 is 1.
7.
C over A is 4 over 2.
Okay, 4 over 2.
And
3
that's
plus
2.
4 is 7,
And
right?
1 plus 2 is
That's
3.
7 over 7, and that is 4 over 2, right?
Yeah. So you gotta add them too.
Okay.
Add the 1 plus the 2 and you get a 3. And then
Which
I think
one? Which
this is-
one?
7 over 7 is 1.
Right, 7 over 7 is 1.
4 over 2 is 2.
22, 1.
And 2
24 is
plus
2.
1 is 3.
Yeah, and then 21 is
So
3.
Miss
Yes,
Barbara,
right.
suppose you couldn't reduce it. You have to leave it like that.
Okay.
Unless, well, the answer is 3. So that's simplified. Unless it said to simplify and you came up with a fraction and you had to reduce it.
Oh.
But if it didn't say to simplify the answer, generally though, your answers are simplified. And if it were multiple choice, which they mostly are, it would be simplified. And we have one more. Okay, number 5, make that one bigger. I want you to do that one and tell me what you get. You have a minus 5xy plus z. So you have x, y, and z. X is 6, y is 7, z is 1. Tell me what you get.
5. X is what? X
Is 6, and y is 7, and z is 1.
42.
Is 1.
42.
1. Y is 7.
43.
Y is 7.
47. It's 6 times 7 is 42. 42 plus 1, 43.
6.
Right, Miss Barbara?
What did you get, Latoya? What's your answer?
40, 47. 48.
Latoya.
6 times 7 is 42 plus 1. 43 and minus 5.
Not yet.
Latoya, this would be
Yeah.
-5 and X is 6
Yeah, I
and
get
Y
that part.
is 7.
Plus
Okay.
1.
And this is plus Z, that would be right, plus 1. Okay,
Yeah, so 7, 6 and 7 is 42 plus 1, 43.
wait,
43
wait.
times.
This is a multiplication.
Yeah, that's what I'm saying. I never finished. I said 43 times 5. 5 is 15 for
Latoya, are you doing PEMDAS?
215. Huh?
No,
They're gonna be
no, no,
43.
no, 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 no. What's a -5 times 6 times 7?
Plus 1.
42
That's 38, Miss
minus
Barbara.
5. 38. 30.
What did you say, Audrey?
38.
That's the answer you got?
Mm-hmm.
No, not
No.
even close.
Minus 5 is 30.
All right, let me go back over it.
30.
5x
30
y.
times 7 is
5
210.
Plus or
Five
minus?
211.
Plus or
A
minus?
minus.
Plus
Minus.
Minus
7,
210
210.
210 plus 1
plus
is
1. What is that equal to?
11 minus 5.
211.
11 is 6.
No, unlike you subtract.
206, Miss Barbara.
No.
209. 209.
Plus or minus?
Oh, it's a plus or
Minus
minus.
209.
That's it.
1 from 10 is
Minus
9.
209. That's the answer.
Oh boy.
Oh, 209.
Yes, you've got to
Look at that.
multiply the
Right there, you know.
5 times the 6 times the 7. There's a negative sign here.
Yeah, negative
So that's
sign.
42 times a -5 is a -210.
Yeah.
And then the plus 1, unlike added, you subtract. Plus you can see you got more minus than plus. So your answer would be minus.
That's 1.
Got it?
Oh, no, I had that.
Yeah.
Yes. 209.
Questions on the substitution?
209.
Evaluating your expressions. All right.
Equals negative 209.
I gotta read this over.
Yeah. I had it 209 there, you know, but I don't know why you say that. Like,
Okay.
because
Those are just answers to what
10 and then I had 1 get to 11 and most of 5 we get. Oh God.
We gotta learn our timetables, Audrey.
Okay, so I think we'll stop here, even though we started late. We're going to stop here because adding and subtracting algebraic expressions, that's what we're going to start on next time. But you will have homework on what we went over today. Okay, so when I send you your session, I'll send you some homework. Well, it's for practice, you know.
Bigger.
Questions? No, don't worry about this. We're not going to go over right now.
You can't see.
We're going to do that. Adding is, oh, okay. Well, let me just make it bigger. Because this is something that you could really start looking at. When you're adding, subtracting, you're involving like terms, and that means, okay. In order to add them, they have to have the same variables, okay?
Adding and subtracting.
Adding and subtracting variables. So
have the same variables?
Yeah, you can combine them through addition and subtraction, but to add the terms, the variables must be to the same power. In other words, like here, if you were, okay, here you got 6x and x, 6x to the second, x to the second. You could add those, right? What would you get, Latoya, if you add 6x to the second and x to the second?
Ooh. Where
Right
you
here.
at? I don't see you.
Right here. 6x to the second and x to the second.
Oh,
If you added those, what would you get?
7x.
To the second.
Yeah.
Yeah, you'd get 7x to the second. Audrey, if you had 14y and 3y, and you subtract 3y from 14y, what do you get?
Subtract 14,
Yeah.
3y,
Subtract 3y from 14y, what do you get?
11y.
That's it. That's right. Now you can do that when you have the same variables. You can't do that if the variables are different. That's the
Okay.
point I want to make here. For the addition and subtraction, you have to have the same variables. And if you have powers, they have to be the same powers. Okay, and the same for subtraction. Like here, you got, when you look at this, this is expression, right? 2x squared, you have x squared here. So 2x squared minus x squared is 1x squared. 3ab plus 1ab, remember the 1 is the default, that gives you 4ab. But notice you combining the same terms, the terms with the same variable and power. You can't combine a x to the second with a x to the third. Okay, they have to be the same power. Got it? But now,
Yeah.
when you get the multiplication division, it's easier because you don't have to have the same variables. And you don't have to have the same powers. But addition and subtraction, to combine them, it must be the same variables, or if it's powers, they have to be the same powers. So you're combining like terms, it's called. Okay, got it? Okay, so that we will go more into this one next time, addition and subtraction of algebraic expressions. We'll be doing some examples, and then we'll get into multiplication and division. And with division, we will be doing some factoring. Okay, so next time, addition, subtracting, and multiplication and division of algebraic expressions. Okay.
Yeah.
Okay.
All right, so we will be continuing with these expressions next time, and we will review what we went over with translating the words into the math, and also evaluating the expressions, like making the substitutions, and you will have homework where you'll practice some of that. Any questions on anything we've gone over?
No, we're gonna learn this. We can go over this here. Yeah, we have
Okay.
to go over it to understand it, you know.
Oh yeah, definitely, definitely. That's what I say. We'll be going
'Cause I
over
haven't done
this.
this yet, but 9 years ago.
Yeah,
That's
this is
what I know.
just an introduction to what we will be
Yeah.
doing next time on this particular topic. I'm just kind of
Okay.
like introducing you to this topic. We adding and subtracting algebraic expressions. We'll get more into that, and we'll also do multiplication and division of algebraic expressions and factoring.
Okay.
Any questions on anything we went over?
No.
Well, we're gonna do practice
Okay.
on it.
All right. All right. You did good. You did good.
Yeah, sorry, my homework was late.
Okay. That's all right. I'm just glad you
I have
worked on it,
church
turned
homework
it in.
too.
Yeah. Okay.
I have
Well,
church homework to do now. Oh,
okay.
God.
Yeah. Latoya gets hers in late, and she's anxious to get answers.
Ah,
Right,
No,
Latoya?
I told you, I have church homework too.
I
I have to do a summary on church homework. I was
really?
going to this church. Yeah, my church gives homework.
Oh my
Yeah,
goodness.
but we had a school going on from last year, and I had to do a lot of homework.
Oh boy.
I had to do homework in church. I was like, damn,
mm.
that's hard.
But you know, some of those, I know I do Sunday school on my Sunday school is 1 o'clock on Sundays. And some of those topics are really involved, and you've got to read a lot of, you know, information on it. And I said, oh,
After all the
goodness.
years I'm going to church, I never do homework.
Well, we have it too, because they said, if it says read this, and they say, oh no, you got to read a little
Yeah.
further. Oh my goodness.
And then we gotta study the Bible too.
Yeah,
Homework alone.
yeah,
and
it's
when they
interesting.
ask you a question and you can't answer, they know
Yeah.
you don't read your Bible.
Right, exactly.
You can't lie. You can't
You're
lie
right.
about
You're
it.
right. You're right,
Because
Latoya.
if you can't answer,
If
he
you
know
can't
you didn't
answer, they
put
know
that
you.
answer for the whole week.
Well, and
That's
then
true.
they will have selected little scriptures to read, but they say, no, don't just read that. Read the whole chapter.
Mhm.
Right.
You may have like 10
Our
verses. They
apostle,
say, no,
our
read the whole.
apostle, I'm telling you, he's a quiet man, but you can't lie to him. He was like, get the devil out of your lying spirit.